Okay, my dear students, today I would like to discuss a concept of smooth inclined plane and rough inclined plane in terms of memory map diagrams, which will help you to understand the concept easily and you will be able to solve the problems in a very simple and smart way. So let us see how many forces are acting on a body if you consider here. Okay, so I have taken a wedge here. So normal reaction is acting in this direction. mg is acting exactly downwards. That means in this direction this is theta, this is mg cos theta, and this is going to be mg sin theta. Okay, so therefore we can take here resultant force acting on the body is mg sin theta here. So we can find out acceleration by using this. So therefore resultant force is going to be equal to mg sin theta. Okay, so as the resultant force is acting on the inclined plane downwards, so therefore it is taken as mg sin theta component here, and resultant force is taken as ma, which is equal to mg sin theta. So mm gets cancelled, a is equal to g sin theta. Acceleration we got, the first term we got is acceleration. Next, in a rough inclined plane, apart from mg sin theta, you will see that apart from mg sin theta, you will observe that even frictional force is also acting here. Okay, so frictional force is also acting, which is equal to mu into n. Okay, so what is n here? You all know that n is equal to mg cos theta. So F is equal to mu into n means it is going to be mu mg cos theta. Okay, so therefore here it is going to be mu mg cos theta. Okay, so what is the resultant force acting on a rough inclined plane? So resultant force acting on a rough inclined plane downwards is the subtraction of mg sin theta and mu mg cos theta. These two difference will become resultant force. So we can write here the resultant force is going to be, it's the difference of mg sin theta minus mu mg cos theta. Okay, so we can write resultant force as ma. M, if you common out, how much you'll be getting? G sin theta minus mu g cos theta. So therefore mm gets cancelled, acceleration will become g if you common out sin theta minus mu k cos theta. So this is going to be an acceleration for an inclined plane. Here this is smooth, means this is going to be rough inclined plane. So we got an acceleration of a rough inclined plane, acceleration of a smooth inclined plane also. So how are you going to find out the time or final velocity? So if initial velocity when you drop the body on the top of the inclined plane is a 0, then here you have to find out the inclined plane final velocity before it touches the bottom point of the inclined plane, which is taken as v here. So we can apply the formula here, v square minus u square is equal to 2as. Okay, so here you all know initial velocity is going to be 0, therefore final velocity is square root of 2a s. Here length of the inclined plane, that is displacement, is taken as length here. Okay, length of the inclined plane is taken as L, which is taken as displacement. So therefore we can write this as square root of 2 into acceleration of smooth inclined plane into L. So therefore velocity of a smooth inclined plane is square root of acceleration, you know, it is going to be 2g sin theta into L. So this is the velocity of a smooth inclined plane. Then what is the velocity of a rough inclined plane when it touches the bottom point of the wedge here? So we can write here also same formula, that is v square minus u square is equal to 2as. Initial velocity is 0 even if it is a rough inclined plane, therefore velocity is going to become square root of 2a into rough inclined plane, and displacement s is taken as length of the wedge, so we can write it as 2a rough and L. So velocity of a rough inclined plane where the bottom of the inclined plane is 2, a means you got a formula here, that is g into sin theta minus mu k cos theta into L. Okay, so we got velocity of the rough inclined plane before touching the ground. that is the bottom point of the wedge. So next we have to find out the time. So how much time it takes to slide down the rough inclined plane as well as smooth inclined plane. Here also initial velocity is going to be 0. So displacement traveled by a block from here to is taken as the length of the wedge is taken as L here. So we can write here S is equal to S is equal to ut plus half at square. At the topmost point, as the velocity of the block and the topmost point of the wedge is going to be 0, so this point has to cancel out. Then you have to find out the time here. So therefore we can take time t square is equal to cross multiplication 2s by a. Okay, so you know here s is going to be L. Okay, s is nothing but the displacement traveled, that is taken as the length of the wedge here. So therefore t is equal to square root of 2s by a. Here 2, s is taken as length, a is taken as g sine theta. Okay, so this is taken as g sine theta. So time for a smooth inclined plane is taken as 2 into L by g sine theta. Let me write once again here 2L by g sine theta. Okay, so time taken for a rough inclined plane can be considered like this. Here also displacement is taken as ut plus half at square. U is going to be 0. Here t is nothing but 2s by a under root. So time rough is nothing but acceleration of rough inclined plane. So therefore time of a rough inclined plane is taken as 2 into L by acceleration of the rough inclined plane is g into sine theta minus mu k cos theta. Okay, so which is the acceleration given at the first block. Hope you have enjoyed the formulas for acceleration, velocity and time for rough and smooth combined together. Hope you have enjoyed this type of concept. If you want this type of some more models in any chapter, you can just message me in the below, comment me below. I'll be able to do the concepts related to free body diagram. Thank you.